Wowies. Hello guys. And today we're gonna be meta programming. Oh, I just heard my other system go to sleep. Wowies. Hold on. Oh, I just closed flat pack Brave. Wowers. Hold on. Sudo pacman SYU. New tab. Close the new tab. Close that. Take us to the other side. Pop this out. Move that back. Go down. And then slightly adjust us. Ah, this is good. Alrighty. Alrighty. Wowies. Nice. And we're in Arch Linux. And everything's good. Why am I putting it on this side? Did I like? I mean, why not? Well, no, that's the side that's easier to see. That'd be stupid of me to put it there. Put it over here. And set to live chat. All right, we're gonna do meta programming, which if you all don't know what meta programming is, it's actually really cool. You can program at compile time. Imagine. But I kind of wish that like you could manually program it at compile time and be like, write code and then the code instantly compiled. That'd be like really interesting, a language design. If anybody knows of a language where you just write the code during the compilation, that'd be really cool. Be like, oh, well, we could write the code out and then run it afterwards. Well, right as we compile, but like I don't understand. Like at compile time, I think it's more like evaluating things at compile time is what it is. I mean, I guess I do understand, but we're gonna check out two programs I've written in here. This one's not even really finished. The idea I have with this one is using a variadic list, and this allows you to basically do things at compile time using this template, right? So you can have a template variadic t. So then at compile time, anything that's in this template can be executed at compile time. So if you had like a static if, static for each, it happens at compile time when you do alias. And so when you do that, it will run and then do a bunch of things. So for example, if I had a bunch of these and I was like, well, at compile time, let's write in some mixins depending on static ifs or something like that, we could have our entire program write itself. Be like, well, if the time is, I don't know, 2 minutes, write this in there or something. I don't know. The usage of it, I'm not sure what you would really want to use meta programming for, but I know that it happens at compile time, and I think it's more for like optimizing. Oh yes, I love Jester. So we're gonna compile mixins. And I'll do some OBJ dumps and shit to show you all. So it's gonna take a minute, and now it didn't really do much, but mixins is just writes a for each mem of members, and so members is made at compile time from this. So if we have 20, 30, and 600, they're 20, 30, and 600 inside of here. However, at compile time, I just divided them by 2, and now when I do mix in meta, it should put a for each loop, which then takes the members and writes out each member divided by 2. So if I do that, it'll just be $10, $15, and $300, which proves that it worked at compile time, because these are pretty much static. They're like just written in the source file. So that's what happens there. However, I reckon we could probably extend this and write it out and be like, all right, if we have this number, we need to, you could technically do some pretty cool stuff with this. I don't know. It's got its usage, but like, I'm still not seeing the full picture, and it's kind of like a very complicated thing to see the full picture for. Especially when this is my most early phases of metaprogramming, and including that into my programs. So here I introduce or use a pragma, and this one, what a pragma does is it just writes out whatever the pragma says to do. So pragma tells the compiler to do stuff like, for example, message member. It would just write it to standard output. And then static for each again, that's nothing new. I don't know why I have I in there, because it looks like I just use member. So we don't need I. And then T, this is a template, so of course, template variadic. We instantiate the template with variadic exclamation point, which passes these to it. So that is what it is. And you can pass a type, a number. You could pass a string if you wanted to, which is what I do down in this section. I pass strings to write, and then I'm attempting to write them. However, this one isn't really fully completed, as you will see. But let's go ahead and do that. Mixins 2.
36 in gesture. 0 C++ 33.
Really? There's LS.
The term object oriented, and I can tell you I did not have C++ in mind.
So this one actually needs some work. And at compile time, it still does the first portion. Are templates the same as impl and Rust? I've never used Rust. I couldn't tell you. I don't know. If you use Rust and impl happens at compile time, I guess. I don't know. But pretty much, this is like the C preprocessor. If you know what the preprocessor does for C, these just get like, the compiler just does this. It just goes, is there a template? Oh, there's a template. Let's figure out what it does. Well, templates are different, but variadic templates are also something else. These are more like a sequence of things that happens. So like, you could have a template variadic, and this is going to take these. And so that's passed through it. So T is now whatever we did here. So T becomes this. And that gets passed down to here. I guess we could also add a pragma for T.length. So like pragma message T.length. I also think there's other things that we could use, like contracts and things. There's also assert. There's so much stuff that happens during the compilation step, but I've been missing out on all of that because I don't really use it until now, which is because I feel like you could do a lot with this. I just don't know where I'm at with it yet, and it's something I just gotta use more. It's kind of like classes. But we want mixin 2.
36 M gesture, 0 C++ 33 M. If you like C++, you don't know C++.
I don't really want it to throw an exception.
Here, and I've yet to see a counterexample other than possibly a few.
We're gonna get rid of all this.
Committee. S. Silvan in Reddit. 0 M.
Okay. Void main. Let's add a mixin. Well, let's not add a mixin. It will just compile. actually, mixin is just a string that you can include at compile time. So if you have a mixin, it's gonna be like, let's do mixin. Hello.writeLN. Semicolon. And then put a semicolon at the end. So basically I'm putting code in a string, and then at compile time, we're gonna put mixin, oh, that goes in here. So that code in the string, we'll just do this dot write line. Now at compile time,
36 Chester.
fuck.
C++ 33 C++ is like jamming a helicopter inside a monitor and expecting some sort of improvement.
Jester's kind of annoying at this point.
0 M 36 Chester 0 C++ 33M. Historically, languages designed for other people to use have been bad.
Wowie.
PLI, Haskell, Ada, C++. The good languages
No
have
property
been
right
designed
on.
for their own creators. C, Perl,
Lol.
Smalltalk, Lisp,
I know what the problem is.
0 M 36 Chester 0 C++ 33N. Whenever the C++ language designers had two competing ideas as to how they should solve some problem, they said, okay,
Let's do both.
so the language is too
Alright, that compiled. And you can see 4 length units.
0 M
So it didn't just give us a length, it gave us length units. So I don't know how that stacks, but that's an interesting thing to note. And then gives us a void, a uint. And so like if you just had a sequence of like, oh, this one's gonna be this one's gonna be that. However you wanted to do that, you could probably for each it. Or you could use like maybe some kind of pre-programmed like neural nodes or some shit. I don't know. Maybe if you could figure out AI stuff better than I can. I mean, I'm not super duper quantum smart, but like I bet you could like have a program that dynamically writes itself, basically. And that's kind of what I want to get to, is where I'm programming a program that will dynamically program itself during the compilation steps, so that way it's the most compiled program of all time. Quantum mechanics, right there. You know, physics. Hit him with the physics. Anyway, here's a fun thing. Let's do nm-o, and then mix in 2.
36 Chester
Oh.
0 C++ 33N.
This is the one where it takes the
It's
T.
probably the only language where the error message can be longer than the program. 0 M 36 Chester 0 C++ 33N.
You'll notice
Repeated as tragedy.
a lot more symbols.
History repeated as farce. Spot K 0 M
There is a lot more symbols here. And the problem is, there's a lot more symbols. It's my only issue with this. So I bet the size of the file is significantly higher because it included so many more useless symbols, I'd say. But let's try compiling it with dash release and see if that fixes it. This does other compile time optimizations. So now, doing this should be a lot less. Although, still a lot. Now, if we just wrote a if we just write a hello world program, and it doesn't include all of the pre-stuff, the compile time stuff, well, that would be a smart thing for us to do. But, that clearly didn't happen here. However, this does have implications for if you wanted to have different compile time assessments of the system. You would just use a bunch of static ifs and be like, if we're on an ARM system, then use a pragma to set the system to ARM or something like that. And that way the compiler knows that it's got to compile it for ARM. So anything that has version ARM can be passed. So it'd be a lot easier to make simpler compilations, I think, which is one of the advantages to metaprogramming in general. Otherwise, it's just for optimizing things. Like if you didn't want to have something in there when it goes to runtime, because runtime and compile time are very big, very important things to understand, I think. Something I don't understand super well, or didn't, but kind of do now. So obj dump dash d, and then we'll do, and that's the entire program. It's going to go all the way up, and there is a lot of instructions and things in that program. I reckon the size of the program's pretty large too. But they seem pretty simple, the instructions themselves. Let's go into delaying and see if I can, wowie. Get like a size on that. 1.2 megabytes. 1.2 megabytes. Both mixins are about 1.2 megabytes. And let's go to a normal, like, program that isn't, like, super big. For example, this one, 1.2 megabytes. Okay. Jester 2 is kind of big, though. 1.3 for the original Jester program. So it's not actually too bad on size of the final compiled file. It just has a lot of names in there that I don't really see when I do most of the decompilation for, like, other things. Or disassembly for other things. But now, like, this could be used to have a config, right? Like, what if we had a program with a config, and you just... So, we have source code, we have a config, you have a text file config that you just have them write to it, and then you have them compile from after they write to it. It'd be really simple. Be like, do you want this? Yes. Alright, then it's going to do that at compile time. That'd be like the ultimate way of using this, I think. Other than like calculations. So let's make a new one. Those are just my examples I came up with yesterday. And I'm also going to open up my web browser so we can do more research into the template side of things. Because I don't really know too much beyond those things. I want to extend what I know, and let's go ahead and go for variadic. Should get us a variadic templates or standard meta. Compile time sequences. Compile time function evaluation, but compile time sequences are the variadic things I was talking about. So these are sequences are important metaprogramming concept that comes naturally from for variadic templates. Yeah, from what I just explained. All it does is give a variadic argument sequence, externally accessible name, so all that it can be worked with in any other context. Available options. Import standard.meta. Checking the length, indexing and slicing. Element assignment works only if the sequence element is a symbol that refers to a mutable variable. A for each, so you can for each these. Static if is symbol, pragma message syn, pragma type of, so like getting types of them. Int string void. Auto expansion. One of the less obvious property of compile time argument sequences is that when used as an argument to a function or template, they are automatically treated as a sequence of comma separated arguments. Oh, like if you pass it to a function, then those can be like the arguments, technically. So you can just put an alias or put dummy inside of something and it will be passed as those. This is actually pretty useful, I think. So template print 0 has a t dot dot dot, and then that can be passed to a function as the arguments. So that's pretty interesting. Let's there's another thing you can do with this though. So this can actually augment templates like normal templates. For example, let's have a template called math, and let's say it's gonna take t or ref t a and ref t b. So we're gonna do that. Then we're gonna go down here. And from this, tmath is like our template. What if we have another thing though? We need another thing for this to work, which is going to be a control kind of value of some kind. So like maybe, I don't know, int, ubyte. Let's say there's only like a few different types of math we want to do. Ubyte type. So we'll pass a ubyte type to it. And so we can have this thing. And then we could probably simplify that by using one of those aliases later. Variac sequence. But we're going to have static ifs. A static if. And then you can take a static if from here to figure out if t equals a certain value. For example, let's say, actually, if type equals add, no, we do type and like 1. Let's get an enum going to enum math, and then that's pretty much an enum. Add a colon to specify that's a ubyte, and then we'll do add equals let's say 0. So if type equals 0, then we can do this, and let's say also in here we can add a sub equals 1, mul equals 2, div equals 3, I mean you could probably do more if you wanted to, but let's go with that. Let's see, so type and 0. So if type and 0, then actually I probably should do equals. I don't really trust that and 0. Well, it is and. It's not like shifting or anything. Let's just do that. And 0, yeah. Yeah, what a great idea. So and 0. Then it will be a plus equals b. I think it's else. But it'd be cool if you had like static cases. This is something I think would be really cool. A static case. You could do an else and then just go down. This would make compiling it kind of slow, but static else, but you don't really want to do that. You would want to do else static if, I believe. I don't know this one for sure yet, so a times equals b else static if, and then we'll have that's going to be minus equals b. A times equals b. And then we'll have another one. I haven't put in the conditions yet that it needs to evaluate. A divided by equals b. That's the compile time math. And so we could have like type and 4, which would actually be type and 3. Type and actually, I should probably call it what it is. It's not type, it's more like operation, but still. We're going to be basically using math enum, so we'll just do math.add, math.sub. Those get passed off to the type parameter. Now, I think we'll come up with a very interesting way of doing that, but I'm not going to do that until after we get a compile that works pretty well. And then we'll see from there what happens. Type and 1. Now, this is cool because this is how you tell a type what it could be, or what it should be, and then if it doesn't have any of those, we can assert that type is greater than 0, or is greater than -1, but also less than negative, or less than +4. So like this. That's our check. So we want to do that because if it's not one of those, then we need to throw an exception. So I need to read up on assert though, because I believe you can throw compile time stuff. This is more like the contract test or contract stuff. Contract programming is something that Ada made. Interesting. So we'll see. It's a way of handling exceptions though. Unit tests. Unit tests are a built-in framework of test cases applied to a module to determine if it is working properly. A D program can run with unit tests enabled or disabled, which I think also happens with the Dash release. You disable all of those. There's contract programming, which we've kind of looked at in the past, but it's like not in my brain anymore. Is the de-assert expression. Assert that optional custom error message. So you could pass this. Wrong length. But I bet you could probably call like a mixin or something, or maybe do a function call here, maybe. I don't know, maybe it's possible. Invalid value. That's what I'm gonna write. And then we'll just save this as a template.d. So we'll save a template.d in there. And then we'll also add our void main. I think another cool thing you could do is scan the entire standard D library with these and be like, do we have any references to these? Now that's a lot of things, but then you could completely remove having to write import. and be like, well, let's import it here if we have this there. So then you have at compile time, you have a thing that reads through your whole program and then goes, all right, let's go ahead and, oh, I found this thing. Let's go ahead and import this this library thing here, whatever. I think that's another thing you could do, potentially. But I feel like that might just be done by the compiler if you include it with import, which, I don't know. I feel like I like the C include more than I like saying import. Because, I mean, what are you doing when you import? Importing it? You're including it. So we could then do tmath. So we have enum up here in the global space, which is kind of gross, but so we have, but that's at compile time anyway. So tmath is going to take let's say we have a equals 2. This is a float 3.2. And we're going to take 3.2 and, or we're going to take A and we want to do comma B. Let's go with like 2.11 comma, and then we have to add, so let's do math dot add. So that's going to do math dot add there. And then we could also pass our, we don't need to do T here though, so let's get rid of that. And then we'll do, let's say we don't know that right line's there, so let's do, let's just import it. Let's do that. That should do. So then if I do right line, I can do a dot right. So that's going to be what I'm going to do. I'm going to right line. And let's go ahead and compile that, or attempt to. Template.
36 M Chester, 0 C++ 33 N. Oh, definitely. C++ may not be the worst programming language ever created, but without a doubt it's the worst ever to be taken seriously. Mason Mueller, 0 M.
Call that oper. I believe type is type. So we'll do oper.add.
36 M Chester, 0 C++ 33 N. C++ simulate wolf's clothing. Beyond Strapstrup. 0 M.
Do float b equals 2.11, and pass it like that. Or we just pass b and a there.
36 M Chester, 0 C++ 33 N. To me, C++ seems to be a language that has sacrificed orthogonality and elegance for random expediency.
Oh, right.
Failure page shows.
So if that can't be read at compile time, what needs to happen is that the string, well, we could create this at compile time to tell it what to do. So this is an interesting scenario where type cannot be read at compile time because it's an argument that's being passed. And so that's where we could go further, since we can't read that at compile time. We could solve that issue by just creating it at compile time, what type it is. But then how do we determine that I even want operation.add? And that'd just be by using a mixin. But the problem is still type cannot be read at compile time. So that is something that you have to have at compile time for the static if, because that's a compile time thing. And so then it comes down to like, well, what is available at compile time that we know of. We do kind of know from the source file that there is a opera.add, but we can't pass that to this. Compiler just gets there and is like, yeah, what were we doing? So one way we could do this is to create a variadic template that contains whatever our operas are, or operations, whatever we want to call that, and just have that beforehand. And so we do like, I think also we could just declare a constant of some kind, but or an enum, and just go through the list. But let's have a template. Do you use blur, my shell extension? What is blur? Oh wait, the is that the one thing that somebody showed me? I don't remember. I'm gonna be honest, that was a while ago. Oh, by the way, you want to see my new background? It's pretty cool, right? Wow, such a great background. I'm really arch-maxing today. Anyway, template, and then ops maybe? I don't know. And this one, because it's a variadic template, it's template ops. We could also just call it op sequence, so like just opsec. Bruh, opsec. Nice. That transparent look for. Oh no, I use Pico com or whatever it is. PyCom. I think it's called PyCom. I don't remember. And this can contain our list of things. Well, this is also a sequence. Oh. Yep, and that happens at compile time. It's a sequence that happens at compile time. We don't need a variadic template. Those are compile time sequences that you can create, but we can... I mean, I guess we could just pass it as is to the template that I've written. Or we could have it figure that out at compile time, what to put there. Maybe we do need a variadic template for math. Or we just take a const. No, we would need it. What am I doing? I gotta stop being so wishy-washy and make up my mind about this. However, this can be determined at compile time if we do it correctly. So we would take this, take our math, right? And these are things we are going to pass to the actual type. So we might even be able to put this inside of there, since the type or the template that we're making needs that. I'm not even sure, honestly. This is something interesting to me. So this is the operations. We'll just call it ops now. And then it's gonna figure this out during the compilation step. Somehow. I'm not even sure. No, let's put this before that. And then make the... Man, this is like brain-racking. Brain-jarring. Oh, wait, where's the docs? Let's pull up the docs. Okay, so you can pass them as like a parameter to a function, is what it says. Auto expansion. And that's passing it as an argument to a function or template. Treat it as a sequence of comma-separated arguments. And so this is where we can pass that. But the problem is, that's not really going to define the type. So, how would we figure this out? That's the real question. I think we would just create our template and let's do that. Let's just create our template, right? Let's just create a template and pass it off. So like, for example, auto variadic. We'll do auto add. Let's do add equals pass it off somehow. Add equals, and then this is gonna make a mixin. But those can't be defined because they're not known at compile time. Unless you had a sequence of numbers, and then that does get known. But that will mix in stuff. Okay, so maybe that's not the way to do it, because that would just be doing the same thing, I think. I think you'd just be passing off a type that happens during the actual compilation step. We have this still. So we have opera.add, but we would figure out how to put that in there. And the way we could do that is figure out what this is before it compiles. But the easiest way to do that would be to do a const. So I guess this is technically a const. However, what did it say here? Type cannot be read at compile time. What are you programming, buddy? I'm programming a. I'm just exploring like the meta programming side of D, which is kind of jarring. I don't know. It feels weird because you're like writing stuff that the compiler is gonna do, but also not really writing stuff that it's gonna do. You're writing stuff that it's going to implement into your code because you wrote it, but like also that's what a compiler does. But it happens during the compilation. It's like you can evaluate functions, you can do stuff, but like it's weird. Like you can do all kinds of weird things. What I'm doing here is I'm going to take a type, I'm going to pass it to this template math, which is probably not a great idea because it is a template, and that means it's also being made at compile time. But we're gonna pass that, and then of course this needs to be like injected in there during the compilation. Type cannot be read at compile time. Yeah, and that's because it doesn't have that. Unless we like container, put it in another container of some kind, like hide it and then passed off like a thing from there to it during the compilation. Could we also do variadic sequences inside of the main? So maybe do variadic, maybe set up a variadic template during the main step. Let's try compiling it like this. Will it throw an exception? Alright, so that's good. Then, I will create a variadic again. So template gen. We'll do t ... This is going to take a sequence, and then we can do these. So we would put paste. Let's do actually for each mem of t. I think that's how I did it in the original. I used Nix, by the way. That's cool. Yeah, I've heard good things about Nix. I've heard it's pretty good. This needs to be a static for each, by the way. I think you can use regular for each, but we're gonna go static. It's for mem of members. This one's for mem of t. And here's what you can do, just like what we did there with the assert. We're gonna use asserts a lot because assert is a very great feature that we should definitely be using. This allows you to check things before they are compiled. We'll do static asserts. Static, and then we'll do our types. What if we could do a constant assert? That would be interesting. A static void function. Assert t dot length is greater than 0. So if t dot length is not even a thing, then I don't know. Invalid there we go. So that's going to do that. And this will mix in our template. So if we have t, we'll call for like mix in and then put math and then the types or whatever. Technically, we could just do our static ifs here and use this variadic template as the actual thing. Because, of course, if you do this, it will just be like a... You can't do this. This is not compile time at that point. However, I think if we do it this way, it would be a compile time feature. Problem is, it may still be like, yeah, you can't do that. But we'll figure that out as we go. We're going to mix in math. This probably means I need to do gen after that. So like cut this, then paste it down here. So we do template gen, and then we'll do math. And math is going to take A, comma, B. Problem is, we don't have A and B yet. So A and B are defined down here. That would mean we would need to define this inside of there, which wouldn't really work. And that's kind of where I get confused. However, we should be able to do this and append A. So if you put a space here and then we passed A as a thing to this, but it will be like the append t, comma. So then we need to pass to the gen template. This is really weird, but quite literally is just then comma and then append. This would also mean we need to be passing array sequences to it, because we're not taking two different t in there. So that only works with one. Yeah, that's smart of me. Wow. I don't think mixin's the right answer for this problem. I think using this to create the actual type of math that we need is right, though. I think I'm on the right track. I'm just doing it in the wrong way. That would be like the worst way of doing it. Well, it wouldn't be the worst way. There's totally worse ways. Probably. I hope. I hope there's worse ways. That was bad. That was the worst, I think, that I could have done it. I don't know. Static assert type. I think we could do all of that in this. And then we just take t and then and mem. But regardless, then how do we figure out which type it is? Or how do we figure out which operation it is? And that's where... So if we have... You need to pass it 3 arguments at once. Let's undo this. So it need to be t of 1. And it'd have to be mem. So we're going to take array sequences, mem0, then mem. Also, these need to be appends as well. Mem1. And then lastly, the rest of another space. And then mem3. So at compile time, it makes this mixin. This is going to get a comma here. And then this is going to get a comma here. And then we're going to append another mem2. And then after mem2, we just have the rest of the equation from here. And that's going to go down onto this line. And this is where things are very fun. Yes. Syntax? Yes. Wowie. So that gets done. And then it's passing all of that. So then we're just... I actually think that's all we need. That's all we need for the mixin. And a semicolon. Is this game dev? No. This is meta programming. But like to make my brain hurt. So if we don't know of a type at compile time, we can use meta programming to like figure out what the type, well, not what a type is. Technically you can do that with a type. But if we have this parameter to this function, and it's assessed at compile time using static if, to figure it out, we could just do this, I figure. So this is like a solution to like a common issue that you might have. I don't know. Let's try compiling it. Okay, then let's try calling gen and take our, well, let's instantiate gen with alias. So alias, and then call gen. We'll do gen. Do you need to do alias gen and then call it wherever you need it? Gen equals and then do like our simple gen exclamation point, and then pass off these to it. A comma B, but it expects a oh, okay. You know what we could do is just do T for each of these. Well, mem. But it's still sequential, so let's pass mem as a... that? Or we just take the mem and put it in here. We don't need to for each it. We don't need to for each this. We can do this simpler. Do this. Now let's get rid of that. I'll reduce my complexity by like 100%. So now we just gotta take T and put it between math. But we could just call it with... No, don't do it that way. Let's not try that. We can remove this. We can remove that. And then just put the sequence in the middle of T. I think this works. I don't know. And then add opera.add. Let's see if that works. Let's see what happens. Yeah, I love this.
36 M Chester, 0 C++ 33 M. I consider C++
Float,
the most
float,
significant technical
opera.
asset to the survival of your project, and do so without apologies. Alistair Cocker, 0 M.
Interesting. So it kind of worked? Incompatible types for math. String and float. Oh, colon string. So did it just get passed as a string? Error. Template instance template dot main dot gen. Error instantiating. So the compiler sees alias sec, string, and float oper. Okay, so if oper.add equals 0 in it, then let's just try passing 0 and see if that works. It might take that as an int.
36M Chester, 0 C++ 33N. C++
Yeah.
is the only current language.
So let's try casting oper.add to the thing.
0M.
Is oper.add declared as a yes? It is declared as ubyte. Cast ubyte oper.add. However, I wonder if... Yeah, sure, why not? Let's just try that.
36M Chester, 0 C++ 33N. Why do C++ programmers prefer dark mode? Because light attracts bugs, nagging FUSMA. 0M.
Wonder if it's a problem with using that in a mixin. But it's also because we could just do this without static if. So if we didn't use static if, and without using a template, which would be another way of doing it, we can still do this without a template. So if we had template and we called it math, then what we'll do, we'll just call math with that template, but have it different. And so if we had this, then we can go in sequence and then mix in the parts that we need. So instead of that, we're taking template math, right? So at compile time, we'll do alias gen. It's going to be math a comma b and oper add. And then we could take static ifs here. And instead, this is a sequence. At which case, that if this is a sequence, then we could, yeah, that's going to be a compile time kind of thing. So doing this allows us to call that inside of the function anywhere. Hello. Welcome to the Arch Linux stream of all time. I'm your host, TH3Fish, and today we're doing templates. I don't know. Static for each, and we'll do static for each, and then math. Quantum right here. We'll do a assert inside of this. But that's probably a bad idea. Do we even need that? We don't even need that. Static assert t oh, but this would be great if you wanted to pass multiple. I mean, I guess this is kind of necessary. Static assert mem of mem2 of each of them. So we're gonna take 3 indexes. So it's gonna pass like sequences of 3. Mem2. I wonder if we could just do that with it like this and then pass it and then take indexes. I think that works. Let's try the original way I was gonna go with it. And then we can figure out doing like sequences at a time, and then in the future do more than that. Static assert t of like 2, and then take t of 2, and then figure out if that's what it is. static assert t2 equals, let's go with opper. But here's where things get interesting. We want to take u by. Well, yeah, is less than 4 greater than 0. T of 2 is greater than -1 and less than 0. Alright, so then this will give us a exception invalid let's try invalid opper. Yeah, invalid opper. That's good enough. Invalid whopper. That'd be great. That's Burger King's next hit meal, by the way. Alright, let's cook up another thing. Let's static ifs. So static if will allow us to take that third index to determine what it is. So static if t of 2 and opper dot add, then we can go from there. And these are basically constants, so they'll be at compile time, and then from here we do it else static if, and we can take if opper dot sub, and then we can do another else static if. We can do a opper dot mole and a final else static if for opper dot div. Let's see what happens here. So then we can do our plus equals a. We're going to take a plus equals b. A plus equals, or a minus equals b. But these are going to be t1 and t2. So you take t1, t0, and t1. And then we'll just switch out the operation every time. So boom, boom, and boom. This is like referencing it without even referencing it. You're just taking that and then changing it. So then that should allow us to create a math and take A and B to math, pretty much. So if we do math, we can hello. It's been a long time. Yeah, I haven't seen you in a while. Let's try opper.add. Then
36M Chester, 0 C++ 33M. C++ is doing Russian roulette, but you're using a magazine-fed gun WXFFLXR. 0M.
And then divide that. And then, let's see, variable name expected after t, not... What do you mean variable name expected after t? Maybe at that point, then we can be like, assign it to this. For that. Not, variable name. T's of 0. I mean, it accepts the t of 2 Are you learning the C++? No. What do you think of Tor, as I'm an I2P user? Tor is pretty nice. I like Tor. It's kind of slow, but it is what it is. It works. It does the job. You gotta be. There's like a bunch of like things you gotta do with it to like to be like careful. Not like it's dangerous, but like because otherwise you still expose information even with Tor. Like PDFs, you have to like screen them when you download them with Tor. Well, that's with anything. PDFs can link to online resources, and then like a lot of them do that nowadays. Let's see. Declaration expected, not minus equals. I see.
36 n gesture 0 C++ 33n. Whenever the C++ language designers had two competing ideas as to how they should solve some problem, they said, okay, we'll do them both. So the language is too baroque for my taste. Donald E. enough. 0m.
Maybe we could do void pointers. I don't know. I don't know what I'm doing with this stuff. I'm gonna be honest. Let's go with let's try creating a void function for each of them, but that's like really. I only want one function that handles everything, and at compile time we figure out what the hell the type's gonna be. So like void. Let's do a void function, and then we'll call it void math. But at compile time we now know void math needs the other thing. First, are you a glowy or an FBI agent? What do you mean, glowy or FBI agent? Me, I like programming. That's it. I was thinking this would work. Oh, wait. These probably need names. And if they're passed, then and we're instantiating that at line, or that's the problem, comes from line 16. Are you sure? Yeah, I'm just a programmer. Variable name expected after T0. Well, let's put a letter. Let's call A and B, then A, and then, but these are actually arrays. Yeah, it thinks these are types, not the indexes of T. So when we pass T2, those work. So taking this, we can't just take the member of T and then add the two together. That's like problematic. This problem comes from a simple fact that it thinks it's a thinks it's an array of T. So it thinks it's a 0T array, which doesn't work. But what we could do is alias in here. So alias can actually save us for once. Alias T0 is going to equal A. And then the other one is going to equal the other thing. T2. I think this will work. Then we just pass it off. Are you building something? Which language are you using? I thought C++. I'm using dlang, and I'm exploring templates today, as well as variadic sequences and some other things. So then we take this, we're going to replace that with A, this is going to become B, see, originally I thought we just got to name them and then it works, but that's not going to work because it's going to think it's an array of, and the name is going to be B, array of 0 plus array of 1 does not even work anyway. So then this should definitely work.
36M gesture, 0 C++ 33M. C++ has taught me one thing. It's this. Just because the system is consistent doesn't mean it's not the work of Satan. Andrew Plotkin.
Wowie. Okay, cool. Still thinks those are not what we need them to be. Let's do static though. What if we have a static T0 and a static
36M gesture, 0 C++ 33M.
storage class?
Is more of a Rube Goldberg type thing.
So those are array objects.
Exploding widgets, spots to get your fingers crushed.
Alright, so
Most of its users don't know how it works and can't tell ahead of time what's going to cause them to lose an arm. Grant Edwards. 0M.
we actually might have to take I don't think this is wrong. I just think that the way I'm handling this is wrong. I don't know, it's a sequence of this. I mean, I don't know. Well, let's do let's try compiling it like this. I want to see what happens if I pass it like this.
36M gesture, 0 C++ 33M. C++ has taught me one thing. It's this. Just because the system is consistent doesn't mean it's not the work of Satan. Andrew Plotkin.
Oh, great. Yeah. So this doesn't work. That's fine. This is okay. Would have been cool to see this work, but I know how to make it work, and that's to not handle this as an array, but to handle it as a sequence. So we could do this using a static for each instead, which would be really slow and not really great at compile time. Unfortunately, none of this really is recommended to do, I feel like. If you value your compile time, I don't recommend doing this kind of stuff. I don't know, it just kind of seems like it slows it down a little bit. Well, at least when you have a bunch of messages that you write. What do you think of Golang? Oh, I've heard of it. I haven't looked at it, really. I don't know. It's made by Google, right? Ugh. I think it's a cool language, but I haven't looked at it. So T is an array, but we have to static for each it to actually figure out what its indexes are. Now, let's assert, well, we don't need to assert, because if array length is greater than 0, and then, or t dot length is less than 4. Well, 3 works here. 0, 1, 2. So that's 3 numbers, 3 indexes in that array. So that should work. Hello, welcome back. And then we'll do, for this step, we need to get the last one first. So we need to start from the high number and go to the low number. So it actually needs to be done as though we need to do add, comma, and then B and A. So it has to be written in reverse. Technically we could just do A and B. It wouldn't really matter because they're going to end up in the same place. We'll do it like this. So then we take opera.add. So equals to, actually on this one, yeah. Well, actually instead, If it does not equal 2, then we assert, or no, we assert it equals 2. Otherwise, invalid t.length, or missing types. Technically, I could add more to specify what's missing, but yeah, you're right. We need to do it like this. T.length, technically, taking it even further, just do an and. I've been told that's more performant, so we'll do t.length and 2. That's a good assessment right there. Now we need to take our sequence. However, I think these need to be constants. I mean, they're there. They should be known at compile time. They don't need to be constant. That's just only a compile time value. So then we have to figure out, well, t is this, so let's add an I, so that way it knows what to do. So the first one we know is going to be the 0 value, and is direct op and on the processor, so yeah, more performance. So if and these wouldn't be static ifs; these would just be regular ifs. No, these would be static. They're in a for each. Yeah, we'll still static them. Yeah, that's what we're gonna do. Static them. Static if. So, but I don't know. It might be like this is not known at compile time. Then the first thing I'll change is the static. I'll take note of that right now. If I equals well, if I and 0, then we need to check what the operation is, and so that's like, well, that's fun because now we have to go even deeper to figure out what it is. Well, no, we just have to take mem and pass it to another, like a void function of some kind. Mean tick time, 93.4340 performance. Let's create a void. Can I even do a void at compile? Sure, why not? Void evals. Let's do a void function evals. Should just be the same as just writing like a normal D type of thing. But this also is not good because this has to be put into here. So I'm gonna just make this a static void. I don't know. Sure, we'll try a static void. I don't know if that's gonna work. We might have to do like another template to make this not greater than 3, but we're just gonna call evals, and we're gonna pass I and mem. So evals is gonna take ulong I and t mem. Hopefully that works, because I didn't put, well, probably should mark it with a T, so it's a void template for right there, and we'll see what happens. We'll go from this. So if I and 0, then we're gonna take t mem. We're gonna determine what that is. So now t mem. Technically, I would do another one, but let's go with another static void. Meta. Let's try static void meta. Call that right here, and then it's just going to take t mem. So then we take our static. For AM. Static if t. So then we'll do t. Do mem and oper dot add, and then from here we're just doing gonna do a sequence of these. So hopefully static voids work. Hopefully all of this works. This is a crazy way to program. So inside of our for each, we're gonna call evals. We're gonna pass off I and mem. So I and mem get passed off. Then what we have to do is, oh, but I'm not thinking correctly about this. You can make a string while the program is running. By all technicality, you could do that. So all we need to do is eval the first member. Then the rest is creating a string out of that. So that would be the function we want. So from there, that all happens during the compilation step. But here we're just evaluating things in a way of doing it. However, we can also use a string to our advantage to like make a mix in from different environmental things that we evaluated. But that's a side note. I don't think that's going to really be useful in this case. Then we'll just call meta. I'm not sure what else to call it. We'll call meta and pass mem to it, which now needs to assess whether what to use. So from here we're going with else, and then we add the static. Else static if oper.sub gives you minus equals, so it'll be this is not gonna work because then this has to go in the middle. Well, theoretically, all it needs to do is assess the first one. Then the second two get passed off as parameters. Hold on, let me rethink this pretty deeply because I think I'm going about this way too complicated. So once we get this first one, we literally have the rest of it, like all of this, but it needs to be broken down into for each. But does it really need to be broken down into for each? Could it just be done with like something else? Could be done with something else. It could literally be done with a template. I think I'm just doing it wrong. We just need a void template which takes the references. Void math. I thought this was gonna work the first time though, and then it didn't, and then I'm like, what am I doing? TA, comma, TB. Those are refs. Technically, you could also probably do concurrency at compile time. I wonder if that's an interesting thing we should try. Const u by we'll just take an oper dot and then take that. Take ubyte oper. We'll do yeah, ubyte. These are like constants. Then it's all about static ifs. However, that also isn't known at compile time. Then how do you pass the And that's where creating a mix-in would probably be a good idea, but a mix-in wouldn't really help, I don't think. Unless you're doing a different way of doing it. Like, let's take, for example, we have like a string, then we take a, and then we're going to append plus equals based off of whatever oper is. And then that's a variadic sequence right there. However, these would have to be passed differently. So this would be like kind of not the best. However, well, I think variadic sequences can take anything. So if we did template, and these, I'm pretty sure, can just enum a string, like, for example, plus equals, minus equals. So these enums just are just associating with these strings, but they can be used at compile time to create our weird calculator. And I think this reaches what I want to do with this program. So there's my compile time stuff. And then all we need to do is create a template called math. So then, based on what is put into that instantiation of math, we'll find out what it does. So math gets brought into the world as t dot 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 dot, which just means it's a variadic template. Means that the type can be different, or the amount of types in there could be different. Basically a tuple. Function wrapper. Fun words that I've heard for this. And we take and it's gonna basically breaks it down. But here's the problem: is that if you have a sequence of these, then well, we need to create a string. So we need to have a constant string, but not a constant string. This is a compile time string. So this string just gets made, right? This string is magic. I don't know, magic string, and we just make it equal to this. I know it's not a proper term for what this string is going to do. Well, it's going to do magic. Okay, it's going to do magic, and it's going to take each index of t, right? So it doesn't need to equal anything. However, the string magic is going to get appended to. Magic appends. We're going to do a static for each, and then mem of t. So then it needs to convert what oper.add is, because it's going to just take the literal oper.add and put it in there. However, since it's enummed, I bet at compile time, when we send the mix-in step, which is this last step, mix-in magic, which is the final step of it. Hopefully it takes that string and makes it. So for each mem of t, then we're going to magic appends that mem. So if we have A and B, boom, that's what we're going to do. Let's see if this works. I think it should. So we're going to generate math.
36 M Jester, 0 C++ 33 N. If you think C++ is not overly complicated, just what is a protected abstract virtual base pure virtual private destructor, and when was the last time you needed one? Tom Cargill. 0M.
Variable name expected after type magic, not appends equals. Declaration expected, not append equals. What? Alright. I mean, technically, this is able to make a string at compile time, I'd theorize. This would be, like, really interesting if it does work. We probably have to convert the types to strings as well. However, it's also writing in the values, potentially. Well, this one worked. Did we static for each it? Yeah. And we're taking mem. Yeah, so we're taking mem. We're taking val divided by 2. But this is doing it with these. And a t. Which really isn't great. Unless you do mix in mem. And then instead of converting it to a string first, you just mix it in.
M Jester 0 C++ 33N. C++ is the only current language making COBOL look good. No translator. 0N.
That's the
36 M Jester 0 C++ 33N. If you think C++ is not overly complicated, just what is a projected abstract virtual base pure version?
So then it needs a constant.
And when was the last time you needed one? Tom Cargill. 0M.
unless you set float a to equal a constant. But it doesn't like that because expects a constant. I don't think this is the way to go. I mean, it's kind of cool though. Compile time stuff. Now, I wonder what other things you could assess at compile time. Maybe like compilation time at compile time. During the compilation. What if you could enum functions? Like, enum functions and then pass them? Like, imagine. Enum, that'd be basically aliasing, but even worse. It'd be like a bigger aliasing. Compile time. Oh my god. But this is like the complex things. Let's change direction. I mean, it's pretty cool to see how templates are useful, but I need to read more. Like, auto expansion is a thing. Homogeneous sequence. An alias sec consists of only type or value elements that are called type sequences or value sequences, respectively. The concept of a symbol sequence is used less frequently, but fits the same pattern. Interesting. It's possible to use sequences of values of the same type to declare an array literal. Yeah. Figured. .tuple of is a class struct instance property that provides L value sequence for each field. I actually don't know much about tuples either. That's something else I think I want to learn about, tuples. But pretty interesting though, like compile time stuff, const chars and things. These only exist at compile time. For example, const char array meta can be passed to mix in meta, and then boom. It only exists at compile time, the entire block for meta. Now, then you can add other implications like at compile time, do this thing or something else, and then create our sequence. Like, for example, what if you had a library that you didn't know what the symbols are in it? So then you created this, and it calls like obj dump at compile time to disassemble that and find symbols, and then reassigns the symbol name into an array. Like, for example, if I have let's do that. Actually, that'd be an interesting thing you could do with this. So at compile time, we're going to we're gonna do this. I wonder if we can even read them at compile time. It's like a really good question I don't really know much about. C preprocessor versus D. I guess if you had, I guess you could just import the source file to the compiler and then generate based off of the source file. But I don't know. That'd be like you call a separate program that then assesses the... That'd be more compiler stuff. The D way. D uses symbolic imports. Textual inclusion of header files. Tens of thousands of lines of code over and over for every source file. Wow, that's pretty amazing. D-Way, hashtag pragmapack. The C preprocessor way. This is used in C to adjust the alignment for structs. The D-Way, struct foo, and then align for. Use 4-byte alignment. What does that mean exactly? Just use 4 bytes. Macros. Preprocessor macros add powerful features and flexibility to C, but they have a downside. Here's an enumeration for the common uses for C macros. The D-way. enum int value. So just switch it with enum and add a few extra things. Define value equals 5, or define value space 5. Wowie. C preprocessor way. D screen. D's optimizer will inline the function and will do the conversion of the string constant at compile time. Supporting legacy compilers, the D way. By making the D compiler open source, it will largely avoid the problem of syntactical backwards compatibility. Type aliasing. Define, you just do alias. An int. I've looked at C before and I've seen define and like all of this stuff. Ref int I, so that's our reference to int I. It's like automatic pointers basically. Pretty useful stuff. Ref is one of the more useful things. If you need a reference of something, instead of taking a duplicate, that's pretty useful. Extern windows. Int, one way of calling conventions can be called in specific blocks. Conditional compilation. is a powerful feature of the C preprocessor, but it has its downside. The preprocessor has no concept of scope, if slash end if can be interleaved with code in a completely unstructured and disorganized fashion, making things difficult to follow. Conditional compilation triggers off of macros. Macros can conflict with identifiers used in the program. D supports conditional compilation, separating version and functionality into separate modules. The version statement for dealing with multiple versions. Code factoring. It's common in a function to have repetitive sequence of code executed in multiple places. Performance considerations preclude factoring it out into separate functions. So it is implemented as a macro. For example, consider this fragment of bytecode. Wonder what OS you use? Oh yeah, if you couldn't tell, I use Arch, by the way. Yeah, by the way, I use... Oh wait, what? Oh shit, this again. By the way, I use Arch. Arch, by the way. By the way, I use Arch. And also Arch... Oh, that's NVIDIA. Oops. I didn't mean to go there. How do you like Arch Linux so far? Yes. I wonder if you could write a compiler using compile time. Augment the compiler using compile time features. Write your own compiler that way. This suffers from numerous problems. I think mostly this is for like... Could be great for interop if you have like a function that like you want to interop with and then it just doesn't work somehow because of like that compile time things. I don't know. I feel like metaprogramming is still over my head, but like the more I work on it, the less it will be over my head. These are just templates. C-way. Static assert. That's the D-way. Any thoughts on Pop OS? I think that Linus Tech Tips needs to get on my level and use Arch Linux. That's my thoughts on Pop OS, by the way. Mixins can define other mixins. Macros can't create other macros. Alright, I got something cursed then. Let's try mixing in mixins. Mixin, 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 and then hello. And then yeah, we'll then create our string right here. So we're gonna mix in our mixin that mixin's a mixin. So we'll see how that ends up. And then we're gonna get rid of all this because this is deprecated. I don't need this. Oh, you know what else I saw? Somebody showed me something really cool the other day. And I wonder if we can get that to work. Try mixin, mixin, mixin. And inside of mixin, we're gonna have our actual, let's see. Delang, throw, and catch. Standard dot exception. Colon, handlers, if thrown, enforce. Oh, this is the contract programming side of things. Well, what did it have again? It has does point, enforce, assert thrown, made point to, assert no, not thrown, collect exception. There should be throw and catch here. catching exceptions. Try throw new exception, right? Alright, so here's what we're gonna do. Try throw new actually just do this. Throw new exception. Exception. And then catch. And it's a string. We'll try catching. Oh, that breaks it. We can't do that. Exception, and we'll do const car. What's up? I'm just fooling around, man. I'm just fooling around at this point. Let's put the constant car up in the top. Actually, let's put a constant string. Actually, I think that doesn't work. We'll just do this. Exception. Nice. Try throw new exception. Exception. Const car exception. Then, after we've gotten our const car array exception, we now need to catch exception. Catch string exception. Okay, we'll catch. Throw new string exception, and then we'll catch our string exception. Exception, and from there we'll go down and do this. But that should be the finally part. What is that text editor, by the way? Kate. It's possible to have multiple catch blocks and a finally block executed regardless of whether an error occurred. Exceptions are thrown with throw. So try and then catch new string exception. Throw new string exception. I don't know. I'm just getting spaghetti. Marchi is Arch? I think it is. Arch based. Let's see. How many mixins can I mix in? 4 mixins? I bet this is gonna break.
36 Mjester, 0C++33N.
Good.
Choosing C++ seems to be a language that has sacrificed orthogonality and elegance for random expediency.
Oh, wow.
Page shows.
Try. Okay.
26 Mjester, 0C++33N. I believe C++ instills fear in programmers, fear that the interaction of some details causes unpredictable results. Its unmanageable complexity has spawned more fear-preventing tools than any other language.
What do you mean try? Try's not good?
That does not overload the whole goddamn human. Eric Mangum. 0M.
Okay, here's what we're gonna do. Let's try this one. Throw new exception, string exception.
6 Mjester, 0C++33N. C++
After
is
XXX
understanding a
exception.
helicopter inside a monitor and expecting some sort of improvement. True Aldrich. 0M.
Okay. Interesting. Throw new while parsing mixin expression. Token after XXX expression. Throw new exception. Exception. Alright, that should be good. This should be good.
36 M gesture.
Damn.
C++ 33N. Whenever I solve a difficult problem with C++,
I feel like I've won a bar fight. Yeah. Fuck.
0 M.
Majored Willard.
M gesture. 0
C++ damages the brain.
C++ damages the brain. U.
Yeah.
0 M.
You'd. Very nice. While string mix an exception, throw a new exception. After, this is just because I'm doing dumb shit. Has exception has no string. So I guess that just what if we could mix in the mixin? What if we alias mixin and then mix it into the thing? I wonder how this will work. Alias mixin. Alias m equals mixin m. This is diabolical. Let's see it happen in real time. Mixin m. It's a self-referencing alias though, and I don't think it will let that happen. So if you have void main m, and then how many languages do I know? Not that many. The only one I really truly know is D-Lang, but then I mess around with other ones like Fortran sometimes. C, V, Odin. Like I sometimes look at other languages to see what I can learn from them, but today I'm just fucking around. Recursive alias.
C++, glacial compiles, same complexity, impenetrable errors, laughable prospect.
However,
basically useless tools.
if we can somehow hide that from the compiler, const char m mix, comma, equals m. Let's say we have this, and we pass mix to m. Now, it's mixing in a string. It has to scan this and go, there's nothing wrong with that. So now,
36 M gesture, 0 C++ 33.
Alright, so that's not gonna work.
C++. There is a much smaller and cleaner language struggling to get out.
This is something I never thought I would do. Try to get a mixin to recursively mix itself into a program. Wow. That would actually be really interesting, because I don't know what would happen. Would the compiler just be like, I don't know what to do at this time? Or would it just start fucking building a giant program that shouldn't exist? However, seems like it's identifying that I'm trying to do that. However, what if I do it even better and I do mixin m? So instead, alias m equals mixin mix, which mixin the alias. However, I think this is out of order, but as long as it's constant, it still can identify that. Okay. And even if we built the string after the fact, even if we built this string after the fact, like did it through some abstract means, then it wouldn't really work out too well. Unless we come up with like a third way of doing it to avoid the recursive boundary. I don't think anybody would ever do this though, either. So trying to mix in m, which is mixing in mix, we already know that's not going to work. Because when you call m, it just equals mixin m, and it's like, well, what do I do? Mixin m. I think after a certain amount of times of going through this sequence, I think it's what it's doing. It checks the compilation. Let's try compiling it with a verbose. Verbose. Should be a thing. V errors? Sure.
I believe C++ instills fear in programmers. Fear that the interaction of some details causes unpredictable results. It's unmanageable complexity.
I hardly believe it's about knowing hundreds of languages. We've gone to new levels. It's about breaking the ones I know. I think a way of getting past this is to call it from a separate, like, linked library of some kind. What if we didn't do the -c portion? And then we'll know that the compiler is still gonna have to do that. Unless it can't identify this, and we cast it as like a better C object file, and then we just call it from there. But, I mean, I guess another way would be to... I don't know how it identifies that. I don't know how it identifies this structure. So I don't know really how to get past that. Unless we were to do some weird quantum stuff. Either way, it's going to identify that it's recursive. Well, we tried doing mixin on that. So what if we did like mixin and then mix equals mixin mix, but also mixin, and then I guess we could. What if we did like a static if? And then call it true, then mixin m. What if that works? What if this is the code we need? Show me some code.
36M Jester, 0 C++ 33N.
Okay.
C++ will do for C what Algol 68 did.
If true, mixin m.
36M Jester.
God damn it. Oh, wait.
If you like C++, you don't know C++. There's a mutual exclusion going on here.
Oh, wait.
Yes, to see a counterexample other than possibly a few of the members of the standards committee.
Let's try something else.
In Reddit.
Let's do task dot execute. Oh no, mixin m equals mix, right? And then it's a self-recurring feature. But also we could call like an alias to like maybe another thread, and then use that other thread to get the mixin to mix. At this point I want to just like throw a new exception and then catch an exception that's like catch that same exception and just calls a recurring exception. So mixin m, which is mix, which is a string, which is gonna mixin z, and let's do another const char. I haven't tried this one yet. So that's gonna be z, and it's gonna equal mixin m, and then I'll have my recurring loop. I hope. So now we're gonna take mix, we're gonna set it equal to mixin z, then we're gonna mixin z, and it's gonna mixin m, it's gonna mixin mix, mixin z, mixin m. Hopefully 3 is enough.
36M Jester, 0 C++ 33N. C++ simulates.
What about -w or no errors? We'll do dash release. Fuck. Okay.
C++ is doing Russian roulette, but you're using a magazine-fed gun WXFFLXR. 0M.
But mixing can like evaluate stuff at compile time too. That's really interesting. Which I don't know, maybe Z just is throw new exception. Sure. I actually haven't really messed around with throwing new exceptions. Try that out.
36M Jester.
Wowie.
0 C++ 33M.
Alright, so you can't make recursive mixins the way I think you can. But
Protected abstract virtual base pure virtual private destructor. And when was the last time you needed?
what if we use a variadic function to do it? Like a variadic template? And just have a bunch of different mixins on my variadic template. And then, but that's also able to do recurring variadics. What if you did a recursion? It is possible to do a alias and then get a recurring variadic error where it like throws the error. Alright, let's try out exceptions. Throw new exception. So this is the contract stuff where it's try and catch. Throw new string exception. And then just exception. But let's not do that. We'll just do E. Actually, maybe it is string. I don't know why it was purple. E. And then I've seen this one. Let's see. Class. God damn. Standard dot exception. Floating point math is fun. Thrown in tests, use assert thrown. Oh wow, that's actually cool. Let's do that one. Assert thrown. Delang assert thrown. Let's see, it takes a T and an E. Import standard dot exception. Alright, so now we're gonna assert thrown, and then we're gonna try taking whatever T is. Can I get an example? Oh, is this core dot exception? Assert thrown, and then you do string exception, and then you do E. Throw new string exception. False and error. E. Then if it's thrown, what does it do? But these are like, this is really confusing. Lots of asserts and I don't know. Assert no string exception was thrown. So like you can catch an exception if your exception didn't go through. I guess that's the idea. Or throw an exception if the exception wasn't exception. What are we doing? Let's go to that. Throw new string exception, and then we're gonna assert that there's a assert thrown string exception, e, and then we'll go from there. I don't really understand exceptions super well either, but these could be useful in the future.
36 M Chester 0 C++ 33 M C++.
Let's put import standard dot exception. Might be a core feature. Probably is. Probably is a core feature language.
36 M Chester 0 C++ 33 M Java, the best argument for small talk since C++.
Is it a string exception?
36 M Chester 0 C++ 33 M.
Alright, it's core.
C++ without the BS. Social pathology. 0 M.
Dream?
M Chester 0 C++ 33 M. C++ is more of a
Template assert thrown is not
full of
defined.
high voltages, large chain driven gears, sharp edges, exploding widgets, and spots to get your fingers crushed. And because of its complexity, many if not most of its users don't know how it works and can't tell ahead of time what's going to cause them to lose an arm. Grant Edwards. 0 M.
It's not defined. So is it removed from the language? This is the issue. I've overcomplicated things. Assert thrown string exception. Try that. Which might compile.
36 M Chester 0 C++ 33 N.
String exception and assert
pile
thrown.
of crap. Theodorot.
Okay.
0 M.
So we have undefined identifier, assert thrown, and undefined identifier, string exception. So those are interesting. That's a template instantiation with the exclamation point. Let's go API documentation. Let's see. Core exception. D array bounds. Oh, actually, that's interesting. So you have array bounds. Bounds checking. Very interesting thing that I heard about being important. On finalize error. On fork error. Classes, aliases. Assert handler. No throw void exception. I think I have used thrown before. But assert error. This is like all like things that are used to build higher level stuff. But there's also standard dot exception, isn't there? Oh, and we're in the stable branch, it looks like, with this reference. They have I'm on rolling edge, so that means we should be on the rolling edge. But there's really not much of a difference, I don't think. I think the only thing that really changes is like being able to call functions without the parameters afterwards. Just being able to have like a void function that takes no parameters. You might be able to call it without ever passing any parameters to it, and just have like, it's interesting. Yo, bro, what you're building? Oh, I'm just screwing around. I'm trying to see if I can break stuff. Assert throw new exception. Articles. Documentation, command line reference. I don't know. I've gone into my evil arc of metaprogramming, and now that I've begun metaprogramming, I'm slowly turning into Mark Zuckerberg. Next thing you know, I'll be writing it all in PHP. I'll be like, damn, bro, PHP. I'm Kokoroni at this point. Language reference, take me there. Where on earth is the error handling? Good, I like this. Reference, I want the docs. Library reference, we want this. Standard.containers, standard.exception. Alright, so here we go. Now let's go back to here. Standard.exception. Then we can assert thrown, and then assumptions. Oh wait, this is better. If thrown. Have you heard of Omarchy? Yeah, everybody's talking about it. I don't know. I don't like it. But yeah, I use Arch, by the way. If you didn't know, I use Arch. If you couldn't tell, I use Arch, by the way. It's pretty obvious that I use Arch. I use FVWM3 as well. By the way, if you couldn't tell, I use Arch. God damn, this is crazy. Enforce if thrown, and then handle. And then also assert thrown. Then we have assume won't throw, may point to. I also want to switch to Linux. Good. Everybody should switch to Linux. There's no point to use something that you have to pay for, like Windows. If thrown, and then E. Oh, those are useful though. Those are kind of like. I think exceptions are handled. No, probably not. I don't know. Can't make an assumption on that. Synopsis. Oh my god, a synopsis. Assume won't throw, assume assert not throw. Huh. Throw new string exception. What is a string exception? Where is that? Exceptions. In the tutorial they say, what is this, editor, VS Code, or what? K advanced text editor. A function called read text. Throw new E, catch E. Potentially invalid user input. Once an exception is found or thrown, the stack will be unwound until the first matching exception handler is found. Oh, these are interesting. They're not compile time then. Interesting. This guide is only about user exceptions. System errors are usually fatal and should never be caught. Oh, but that's fun. Oh god of Notepad. Oh yeah. Just imagine writing 300 lines in this. I've done it before. It's not bad. It's actually really nice. Assert thrown string exception. Enter a safe world with no throw. You're never safe when I'm around. I'm going to add standard.exception and have it throw a new exception for assert thrown E some way or another. Throw custom exceptions. Enforce string exception. Where does string exception come from? Control F. String exception. So how does enforce work? True and then error. So if the exception is thrown, we could do exceptions. I don't know. String exception, enforce. Enforce string exception. Maybe if I add enforce. Exclamation point. Let's see. See if that works. I don't know.
36M gesture, 0 C++ 33N. C++ is like jamming a helicopter inside a Mayada and expecting some sort of improvement. True Albridge.
String exception though. D-lang, string. It's a type of some kind. I mean, it is a thing. I don't know why it's not taken throw new string exception. You using mouse? I thought people on Linux don't use mouse. I don't know. Maybe you thought wrong. I don't know. I'm not a big hyperlink guy. Damn. Wait, void assert thrown? Asserts that the given exception throws the given type of throwable. The throwable is caught and does not escape assert thrown. However, any throwables will escape, and if no throwable is of the given type is thrown, then assert error is thrown. Here, let's get rid of that. Let's try going back up to here. Let's just try throwing an exception. So throw new exception. E. Let's try that. Then go from there.
36M gesture, 0 C++ 33N.
Ah, that's what I did wrong.
More of a Rube Goldberg type thing full of high voltages, large chain driven gears, sharp edges, exploding regions, and spots to get your fingers crushed. And because
Undefined identifier
most of us
string
users
exception.
don't know how it works, and can't tell ahead of
So
time,
a new
don't
exception
call it
works.
0M.
Assert.
36M gesture, 0 C++ 33N. C++ is probably the only language where the error message can be longer.
Oh, I'm breaking things today. Today is the day of break. That's what I feel like. I'm gonna break some stuff. Assert throw. Exception. Is this assert thrown? Yes. Assert thrown. Exception. E. Do 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 do. This is gonna be good.
36
Oh.
gesture,
No
0
property
C++
op call
33N.
for object at exception.
C++ is the best example of second system effect since OS 360. Henry Spencer. 0M.
Maybe enforce. Let's try that out. Oh, it worked. Dot slash template. Let's see what it does.
36M gesture, C++ 33N.
I think it's good. It's
Plus is the worst to be taken.
assert throw new exception.
Fit in. Asking for a friend. Mason Wheeler.
No, it did throw an exception. Ah, okay. So if we throw a new exception, could we somehow assert that we've thrown a new exception inside the exception? Oh, but then it's like the other recursion. But what if libc start main? Ugh. I mean, it worked, but like, at what cost? We didn't get very far. I also see a lot of functions and then like one type at the end. All functions and then one type of some kind. It could be anything really. Interesting stuff. But those are addresses for the stack as it unwound the stack down to libc starting and then went down further. Very interesting. I don't know. Let's see what else there is to screw around with. We got exceptions. Nice. Server reading. New to programming. Not really. Been doing it for months. Let's see. Delegates. Oh, this is something else too. This is something we did recently, was delegates. So with delegates, I was able to do extern C stuff. So with a delegate, you might have like a C function call. And if a C function calls another function, then you would need to have a call for that. Pretty much. It's pretty self-explanatory. Not really much to explain about it, but I haven't really messed around with it and using D functions, just extern C stuff. So like if you have I don't know, let's say we have, let's make a void and it's gonna, I don't know, it needs to call a void function, I don't know, int function. I think they have to return types. I'm not too sure on that. You might be able to call a void function and then use pointers to pass addresses. Let's do a void and then pass back stuff through that. This would just be you take a reference of the data that gets passed into it. So then both of these are going to take, what did I just break? Both of these are going to take A and B. Let's make those int A and let's do string B. Let's change it up. String is a car array, so let's say we have a thing like this. Now we need to give this a name. We're gonna call this the callback. So that's the function, and it takes an int by reference and the string by reference. And then let's go ahead and do this. Which I haven't really messed around with these a lot. This is something I should work on. But it takes B and A as well. The last one, instead of just taking int A, I mean, this could be okay, but we're just going to do this. Take a string B. So this takes a pointer to string B and int A, which means all you have to do is pass A to it. Let's pass int A here. I changed my mind. We'll pass int A here. It wants a pointer though in the function callback. So we're going to use that here as well. Do we really need that though? What if we just had a void pointer? A lot of times when you work with like the C stuff, you have like a void pointer, but that's because it's passing any data type. Technically you could, or technically you would do that and you just cast it to another type. I'm not going to extern C here because I want to try it out with D and just do D exclusively. Let's see. So callback needs to take these types. So we already know that. So callback could be as simple as write ln, and then we'll just write out the addresses for those. Let's do int, well, let's do A, and then let's do B. The address of B. So those are addresses for those. Hopefully. Hopefully it doesn't just, you'd have to do like You just have to write out A and B to get those. That looks good. It's not really doing anything with them. Don't know why it needs to take a pointer. But that's fine. It will do that. And from here we'll just I don't know. We'll also write out the character of B that corresponds to the number in int A. So for to get that, you would just do write ln. Actually, we'll do it reverse as well. So we'll take a reverse function calling syntax b a dot write ln. Instead of doing write line, you can do dot write ln. I always love that. That's my favorite. Then all I have to do is create a and b. So let's just make a equals 24. Oh no, a equals 3, and then b equals hello world. Pretty simple. Then I'll just take I'll call my void function. I didn't give it a name. Oh, very fun. Verifun. Nice. We'll call this verifun, and then we'll take the callback, comma, a and b. Perfect. This should work. Keywords should.
36 in gesture. 0 C++ 33N. If C++ is the
Oh,
to
right.
be taken seriously, where does PHP fit in?
Asking for a friend. Yeah, I'm asking for a friend too.
0 and
How did Mark Zuckerberg make Facebook so good if he wrote it in PHP? Right, it's an int pointer. So an int pointer will take that, and then probably this. Unless we did like, and these have to be addresses then. So instead, we're just gonna take int a and string, and we'll do these as ref. We'll try that out. See if that works. Then these have to be taken as pointers, but they should be able to do that automatically. We'll see.
36 in gesture. 0 C++ 33N. It has been discovered that C++ provides a remarkable facility for concealing.
But it's like you call two functions at once though.
Such as where its bugs are. David Capel. 0 M.
Like honestly, this is like calling where it's calling the function using the second half of it. So I just had string in this here. You then need to have a pointer for both a and b. So you just do a, and then probably b. So that way it sends the address, and then you get these over here, and you just. So then it needs that.
36 M gesture.
Or it needs a pointer.
33N.
Or we're just doing the thing where you like
Talks in C++.
keep switching it up until it eventually works.
0 M.
Int string. Right, it expects a void function, right? Yeah, okay. Callback of type void to void function with 2 pointers. Anyway, we'll just pass those, then we'll use pointers to those, and it should work. You don't need anything here. That's how you can call that. And then we call string b. Let's see what it throws. A.
If C++ is the worst to be taken seriously, where does PHP?
Oh, it's trying to convert it to a ulong.
Mason Wheeler. 0 M.
I see. So in that one, it's taking. A U long. Unsigned long. That's fun. We'll do U long A equals 3.
36 M.
Oh, wow, nice.
33N. Keeping somebody from using C makes me feel like I saved a life. 80.
Yeah, we're still taking. Yep, we're still taking these. Should work.
36 M. Chester. 0.
Alright, we've made progress.
Within C++, there is a much smaller and cleaner language struggling to get out. Beyond Strauss.
And then you have to give it addresses. Since it wants an address to write it out, then these are addresses now. So you'd have to take those and make them back, unless you want to, I don't know, use the addresses for something.
36 M. Chester. 0. C++ 33N. C++ is probably the only language where the error message
Cannot
will be longer
implicitly
than the
convert.
program.
Type U-long pointer to U-long. Ah, right. Oh, so it wants those two. Okay. Too few arguments. Expected 2 got 0. What? Okay. Oh, okay, so maybe we don't have to send pointers. Simplify it. But that wants a pointer, so send a pointer. This one wants a U-long and a string. So we're going to send a U-long and a string there. The other one gets pointers. And that should be the simplified answer to the problem. But, of course, using these correctly is also important. So, like, not just randomly trying to do this until it just compiles, I guess is kind of important. Because they do have a...
Gesture. 0 C++ 33N. C++ has taught me one thing.
Does not expect addresses.
Is consistent doesn't mean it's not the work of Satan. And do plot here. 0
And I guess you could cast it to the U-long pointer instead. Oh, those are correct. Okay. Let's let me extend this. Let me extend this out so I can look at it. Cannot pass argument callback of type void to parameter void function. Callback declared here. Maybe it'll just work.
36 M. Chester. 0 C++ 33M.
Oh boy, I sure hope I fix my overclock.
C++
Clueless.
doesn't know the difference between increment and excrement. As Metamoran. 0.
I sure hope I become a C++ developer someday. So I can hate programming. Cannot pass A of type U-long. Yeah. Oh, okay. I know how to fix this. Watch me cast it to a pointer. This is gonna be evil, I think. I think this is probably the most evil way of doing it, but I don't know why I decided to try to do something with pointers as well. String pointer. Oh, this one needs to be string pointer B.
96 M. Chester. 0 C++ 33N. Keeping somebody from using C makes me feel like I saved a life. 80.
Fuck!
0.
He just said keeping somebody from using C. C's amazing though. I love C. Here, what if we did, instead of this, let's just do a number, and well actually, let's just do that. Let's just do simple. Let's keep it simple, stupid, and then work our way up to putting addresses instead, and then using pointers. I mean, it's not that complicated, but like, still.
36 M.
Why is it not callable?
0 C++ 33N.
Void function.
C++ damages the brain. U. 0.
I wonder if it wants an extern C. But if it's extern C, you can't use write-align. This is more for like, you mainly use function for other stuff. Does not expect a void function though. But we're passing a void function. What the hell? Unless that's on 18. That's on the line. And then 8 is the declaration of it. And then 18's where it gets mad. It's like, no, you can't pass void ulong to very fun, the function very fun. But I'm passing it to them. It should do the thing. Very nice. I don't know. Function callbacks are a thing though. Function type is awesome. Anonymous functions and lambdas. As functions can be saved as variables and passed down to other functions, it is laborious to give them their own name and to define them. Hence, D allows nameless functions and one-line lambdas. Lambda, internally converted to the above. Auto F equals. Oh, so you take a. Let's say you have a return value function that basically allows you to simplify what a return value function is. It's like instead of let's make a calculator program then. Do that and then I'm great at typing, by the way. I hope this doesn't hurt people's brains when I type. Every keystroke is giving you a stroke. I'm so sorry. Let's continue. Very fun. Not callable using types. Void ulong string. Okay, I don't really care. Let me clear that all out. And we're good on RGB. Anon function. Oh yeah, need some anon functions. So let's do. It's been a while since I used case and switch, but let's try to use some more of the meta programming features and then implement lambdas with them. So well, how would we do that? That'd be so pointless. Just put a lambda and then write the line. All right, let's do case and switch. Or I mean switch and case. My bad. What am I doing? Switch, and then we're going to read ln. Then we need to enum. So we can do this using an enum that we make. We're going to make an enum. This enum can be really easy. So all you have to do is take, we'll call it enum opper, just like we did in the earlier example where I tried doing a compile time calculator, which would be like really complicated, or a function that at compile time determines whether or not you meant to do a plus or minus. But you could do that using lambdas, and it makes more sense to do it with lambdas. So why would we make a template that's compile time? Let's just do things that make sense. And so we're going to do add equals the string plus. And we're going to parse down a input, right? So you'd read a line, then you can parse that line. You need to parse your function and some other stuff. Sub. And so all we need to do is strip down a sentence to this. Also, that's not how you enum. Get good, nerd. Ha, ha, ha. Mul for multiply. And that's going to be this. So if it finds that token, which means we need to tokenize whatever we put into this calculator, but we can easily do that. It's not hard. It's not like AI tokenization where it's like your brain cells start to rot away and slowly you realize that all that's left is GPT, Chat GPT, and you're like, damn, bro, my brain just vibed itself. I'm like, damn, I'm cooked. So let's make switch opper. So now, what's gonna get passed to opper is gonna be whatever conversion we do. So no, this is actually used for the other portion, but that's used to enum those strings that we could receive. Then we need to create a parser function. So that's going to be a string function. Actually, we could just do it with canFind. We'll use standard.algorithm searching. We don't need to break it down into tokens because we're not converting it. So, oh, it's 521. Standard.algorithm.searching can find. So we'll do that. So we'll do a switch based on can find. But I think we're gonna have to save this for next episode. This is gonna be my calculator Mark 45, my 45th rendition of calculator. But we'll save this for next time. Thank you all for watching. See you guys next time, and